So we're going to just jump right into it. This is going to be problem solving. Scroll down just a little bit so that we have as much of the page as possible. The question or example we're going to do together says the area of the given figure can be written as a trinomial in the form, and it gives you ax squared plus bx plus c. Determine the values of a, b, and c. So remember when we see these questions and it says in the form, and then you get this thing? That just means your answer should look like this. So your answer should have an x squared term, an x term, and then a constant, no x's. Right? And then you should have a number in front of each one of those things. That's what the A, B, and C are. It's really just a way of confirming you've done it right. So if you do your whole question and you end up with 6 terms, then you've made a mistake somewhere. Right? It's kind of nice to know that my answer should come out looking like something. It's meant to help you, not confuse you. Right? And you see this stuff all the time. Awesome. It says that the area of that figure can look like this. What do we know about area? Not a lot, hey? Anyone know any area formulas? Maybe for like a rectangle or a square?
Length times width.
Yeah, length times width, right? So I'm going to put that up here. Area equals length times width. For rectangles and for squares, that works. We're going to need another one, but we're going to talk about that in a second. So if we look over here at this crazy shape, if we assume we only know length times width, then we have to break this thing up into rectangles and squares. All right, so to do that, you're going to draw invisible lines, or I draw dotted lines. Right? I'll do them in black so that they kind of actually, yeah, because it's supposed to go. So, for instance, the first line I would draw is if I put a line right here. That gives me a rectangle down here. Hey, we see that nice little rectangle? I'm going to highlight it and let's do bright green. Okay, so that's one area I can now calculate because it's a nice little rectangle. If I look up at my top shape, I have a little bit of a predicament. Right? I can't quite calculate that. It's not a rectangle. The reason it's not a rectangle is because there's this angle on the end. So I'm going to draw on another line. I'm going to draw on a dotted line right here. The reason I'm drawing that is now it gives me a rectangle on the top. Let's get another bright color in there. Let's go with a nice bright color. Perfect. The only other one that we have is this awkward little spot in here. And this is a triangle. Okay, we're going to deal with that one separately. Okay, we're going to work with the rectangles first because that's more likely what we're used to seeing. And then we're going to talk about how to tackle that triangle because the triangle is a little bit confusing. All right, so if you wanted to figure out the area of this shape, I'm going to have to figure out the area of the green rectangle, and I'm going to have to add the area of the blue rectangle. Correct? Awesome. Looking at the green rectangle, you need a length and a width. I'm just going to call it green. Okay, so if you're doing the area of the green, the length would be 2x plus 3. The width would be x plus 4. And we know it doesn't matter if you mix those up because multiplication is the exact same. Right? So if we do area of the green, 2x plus 3, that's length, times width, which is x plus 4. We need to multiply those two guys together. You can use any method you want. All right, so if I use distribution, I would take the 2x, distribute it to the first x to get 2x squared. Then I take the 2x and distribute it to the 4 to get plus 8x. Then I take the 3 and distribute it to the x to get plus 3x. And then I distribute it to the 4 to get plus 12. My last step is going to be to combine my like terms. That means the area of the green side would be 2x squared plus 11x plus 12. That's the area of the blue the green shaded region down here. Doesn't seem bad, right? That was like the easiest zone. Right? The light blue zone is a little bit trickier. The reason the light blue zone is a little bit trickier is the length and the width aren't easily given. One of them is, but one of them isn't. Right, so if you look at that light blue zone, red, I have a length of 4x plus 9, but that goes from here all the way to here. Our rectangle only goes to this spot right there. So we need to figure out the distance from that spot to that spot, not all the way across. Other problem that we might have is that we don't know this area from here to this area right here. So we have to somehow figure out these two new lengths. There's different methods you could take, okay? So there's no like perfect way to do it. Well, there's multiple perfect ways to do it. That's what I'm gonna go with. Okay, I'm just gonna show you what my brain sees and how I would tackle it. Okay, I'm gonna start with the left side. Okay, this one right here. If I wanted to figure out that gap, what I would do is realize that the entire graph is 3x plus 6. Right? They told me it's 3x plus 6 from here to here. And I know it's x plus 4 from here to there. So if I were to take 3x minus 6, 3x plus 6, which is the entire width of this shape, and then subtract x plus 4, that would give me the missing side length I want. Right? I'm taking this whole gap and I'm subtracting off the little side I don't want. And it'll leave me with what I do want. There is other ways you could have done that. I think this is the best way. Remember that this negative would come into the bracket, so it becomes 3x plus 6 minus x minus 4. That means my little gap up there is going to be 2x plus 2. Awesome. Maybe I should leave one boundary up there so it's pretty clear. It's from here to here. We're going to use the same type of trick to figure out the top side. Alright, because we don't want all of 4x plus 9 because that's too far. So we need to somehow figure out this gap from here to here. Right with that big arrow. The way I would do that is instead of subtraction, I would use addition. So if I look, from here to here is 2x plus 3. That's the same as there to there, 2x plus 3. Then from here to here is x plus 4. Coming from here to here is x plus 4 as well. So I could add these two to get the gap across the top I actually want. To add those two, that means I would go, I need to change the color so it sticks out. Let's go with red. 2x plus 3, and then plus x plus 4. Again, if you put brackets, that's fine, but when you bring a plus sign into the brackets, it doesn't do anything, right? So that's why I'm not putting brackets. If you add those together, that means it's 3x plus 7. So the question mark was 3x plus 7. I'm going to let people look at that for a second and be like, okay, I know what's going on, or I am so lost, I need help. That 3x plus 7 goes from here to here. While we're on this trend, what would this little gap right here be? We'll do red. From here to here. Right, so if we're still using that same logic, 1x plus 2. Yeah, how'd you get 1x plus 2? You subtracted it, right? You took the big side, which is 4x plus 9, and you took the little bit, which is 3x plus 7, and you subtracted it. And so you can also figure out this little side is x plus 2. And I figure we might as well write it in there while we're on that trend anyway, right? Okay, so we got the area of the green side already figured out. That was the easy one. We've now figured out the length and the width of the rectangle for the blue side. So now we can figure out that guy. Just gonna scroll down a little bit. Where do I want to put this? Let's put it right here. Blue side. I'll do it in a different color, don't worry. The blue side. You want to do length times width of that blue rectangle. That blue rectangle's length was 2x plus 2, and the width was 3x plus 7. 2x plus 2, 3x plus 7. Again, you can multiply using that any way you want, right? So distribution, or you could use area diagram. I'm going to use distribution because it just saves me a little bit of space, and I'm short for space. When I distribute the 2x across, that would give me 6x squared. When I distribute it to the 7, that gives me plus 14x. Then the 2 comes to me plus 6x. And then the 2 goes across to be plus 14. You combine your like terms, and the area of that light blue rectangle would be 6x squared plus 20x plus 14. We now have the area of the red, what was the color? Area of the green, and area of the light blue figured out. Okay, this was the green, this was the light blue. If you look at your shape, there's one more little area we have to get. It's that purple area up there, that triangle. Okay. If you got that on a test, they would give you the formula for area of a triangle. Okay, so don't worry about memorizing it. If you do get a triangle question and you don't have the formula, say it to me. Be like, what's the formula again? And I'll tell you. Right? The area for a triangle, base times height divided by 2. And for this triangle, we now know what the base and the height are. The base would be x plus 2. The height would be 2x plus 2, right? The same width as that blue rectangle. It's the exact same height. So that means if we want to figure out the area of the purple, I'm going to scroll down so it's all beside each other again. The purple. We would do base, which was x plus 2, is that what it was? Thank you. Times height, which was 2x plus 2. And we we would divide it all by 2. So it would look like that. The way you're going to handle that division, because that's new to us, right? We're like, I don't know how to handle that. Do the multiplication on top first, and then we'll talk about the divide by 2. All right, so don't stress that divide by 2 yet. On the top, I'm going to do distribution again. Okay, so when these things distribute, it's going to become 2x squared plus 2x plus 4x plus 4. All divided by 2. If you combine your terms on the top, that means you have 2x squared plus 6x plus 4 divided by 2. Okay, and you learned this a long time ago, like how to divide a polynomial. Like you should have seen it a little bit in grade 9. You probably forgot, and that's fine, right? Like we usually reteach it again in grade 11 because people forget again after grade 10 too. When you have a polynomial or many terms on the top, and then you're dividing by something, you can divide that number if it divides into every single coefficient. So for instance, if you look at this guy, I could divide this coefficient by 2, this coefficient by 2, and this constant by 2. If you can divide everything by 2, then you actually do the division. If you can't, then you leave it as a fraction. In our case, we can, right? So we divide every single number by 2. When you do that, you figure out that your area of that triangle would be 1x squared, because 2 divided by 2 is 1, plus 3x, because 6 divided by 2 is 3, plus 2. All right, we have figured out our 3 areas. This was the green rectangle. This was the blue rectangle. And this was the triangle. You have figured out the area of that shape, but in 3 different chunks. So if you want to figure out the area of the entire shape, what do you think you should do with these 3 chunks? You got it. Add them together, right? So you're going to add all 3 of these polynomials together. You could do that in 2 different ways. Some people like to write it vertically, right? So you go this polynomial plus this polynomial plus this polynomial, stack them basically. I prefer to just write them out in one big string, right? And just make it a massive thing. So I would do it like this. I do the first one, I go 2x squared plus 11x plus 12. That's the first one. Then I go plus the blue one, plus 6x squared, plus 20x, plus 14. And then I would go the purple triangle, plus x squared, plus 3x, plus 2. I just like it like that. I just put it one big string. That's what I'm used to. That's how I always learn it. If you've learned it to put it vertically, that's fine. You can do it that way too. At that stage, I combine like terms. So that means all my x squares could be added together. I have 2x squared plus 6x squared plus 1x squared. That would combine to be 9x squared. Then I'll add all my x's together. 11x plus 20x plus 3x would be plus 34x. And then my last terms with no x's, right, my constant, I would add those guys together. So 12 plus 14 plus 2 would be plus 28. This is the area of that shape. Kind of a crazy question, right? Very challenging. You have to be able to picture what to do, like big picture things to be able to tackle that. But when you break it into individual chunks, it's really not that bad. And it's just kind of a lot. That would be like the biggest question on your test, probably. Awesome. If you remember, the question said that you were going to have a format of ax squared plus bx plus c. They told you earlier that your answer should look like this. Ax squared plus bx plus c. You have that, right? So in our case, we have 9x squared. They had ax squared, so then a equals 9. They said you'd have plus bx, we have plus 34x, that means 34 is b. Then they have plus c, where we have plus 28, that means c is 28. Right, so you can match them up with each other to see which letter's which. Awesome. The next part of this question is a little interesting. So it says, calculate the area if x equals 2.15. I'm sorry, 2.5. They're telling you to take that value of x equals 2.5 and put it into your area that you just figured out. That means change the letter x to be 2.5 and then put in your calculator and get an actual value for your area. How that would look is we would take that, we would say, okay, our area was 9 times x, which is now 2.5, squared, plus 34 times 2.5 plus 28. That's how the substitution would look. You change all your x's to be 2.5. And then you use brackets, right? It's really important you use brackets. And you put that in your calculator. If you put it in exactly like that with brackets, it should work. I'm going to calculate it just to make sure. You should calculate it too to see if you're doing it properly. So I would go 2.5 squared. I got 169.25. Right, so if you put that in with the exact way I have it, you should get the same thing. Let me see. Oh, I did not. I got something different when I put it in the exact same way. Oh, that's because I put it in 35. No, I got it the exact same. Right, so if you put it in exactly like that, using the same brackets I use in the same spot, you should get 169.25. The big thing is usually the brackets. Right? Make sure you put 2.5, make sure you put 34, right? Like make sure you did everything properly. Maybe you just typed a number wrong or something. People got that? Yeah. I see a few people nodding saying they got that. All right. One more. A rectangular garden with length and width contains 3 square flower beds, each with side length 2a plus 5. The remainder of the garden is grass. Draw a diagram to illustrate this information. Write and simplify the expression for the area of grass in the garden. Okay, let's start off. A rectangular garden. A rectangular garden with length of 8 minus 3a and width of a plus 8. So So let's draw that. We have a rectangular garden. Whoa, not very rectangular. Width of 8. We'll say length of 8 minus 3a. Width of a plus 8. Fantastic. It then says, contains 3 square flower beds, each with a side length of 2a plus 5. The remainder of the garden is grass. So we don't know where these square flower beds are, right? They might be right in the dead center of it all, right? Or it might be like off into a corner. My guess is that if this is a flower bed, they probably put their flower bed like this. 1, 2, 3. Right? They probably put 3 in the middle. You can walk around them and garden in them and all that fun jazz. They said that they're squares with length of 2a plus 5. And they're all the same, right? So they're all 2a plus 5, all the sides. Draw a diagram to illustrate this information. Beautiful. I've drawn that to illustrate that information. Not a very good drawing. I hope yours is nicer, but it'll work. Write and simplify an expression for the area of grass in the garden. So if you remember, it said that the remainder is grass. That means all the stuff outside of the garden bed. So this stuff is the grass. All of that. And then a little bit of it. And a little bit of it. Okay? It's all the outside, around the square flower beds. You're supposed to figure out the area of the grass, like how much grass there's actually going to be in this thing. Any suggestions for how we would tackle that question?
We find out the area of all 3 squares, and then find the area of the red rectangle, and then you minus the area of the blue squares to the.
That'd be perfect. You find the area of these 3 squares, subtract away from the area of the big thing, right? Which is the big red rectangle. And that'd be perfect, right? Because what you're doing is then taking this big thing and basically punching holes into it, right? Exactly how we would want to do it. So that's exactly what we're going to do. We're going to find the area of the big red thing, then we're going to subtract the area of the 3 blue things. We'll start with the area of the big red thing, right? So if you want to do the area of the big red guy, you're going to do 8 minus 3a, that's the length, times the width, a plus 8. You can use any method you want to do that calculation. I'm going to use, actually let's do an area diagram, because it's been a while. So 8 minus 3a, across the top, and then a, and then 8 across the bottom. Awesome. When you fill out the inside, a times 8 will become 8a. A times negative 3a will become negative 3a squared. 8 times 8 is 64. And 8 times negative 3 is negative 24a. Those 4 things on the inside, those are your area. And you can combine like terms as well. I'm going to do it all in one big swoop. So we have negative 3a squared. I have 8a and negative 24a. Those would combine to be negative 16a. And then I have plus 64. That is the area of the red rectangle, like the whole thing. Oh, yeah, go ahead.
Oh, wait. I see what it's saying.
Okay. Now we need to take the areas of the blue, right, and subtract them away. So I got to calculate the area of these blue squares. All right, to do just one of them, you do length times width. Okay, so let's do length times width of just one of them. The length is 2a plus 5. They never gave me a width. What would the width be? 2a plus 5, because it's a square, right? So just remember, on a square, all sides are the same. They like to do that with little lines like that. Right? So if you see lines on the side, that means those two lines are the exact same side length. And that means these are all the same too. Okay? All right, let's do the area of 1. So 2a plus 5 times 2a plus 5. You could do area diagram, or you could do distribution. It's your call. I'm going to distribute. So if I multiply the 2a across, that's 4a squared. Multiply over there, that comes plus 10a. Inside is another plus 10a. And then 5 times 5 is 25. Again, I combine my like terms to get 4a squared plus 20a plus 25. That would be the area of one of my square gardens. I need to do that 3 times. Now you could calculate it 3 times and add them all together, and that would tell you the area of all 3 blue squares combined. Or you could do this. Times 3. Right? If I have one, like if that's the area, and I have 3 of them, then I do that area times 3, that would tell you how many there are, or the total amount of area for the blue square garden. If I times by 3 on the outside like that, what do I do with monomials? I distribute them in. That means the area of my blue would be 12a squared plus 60a plus 75. You now have the area of the red, which is the big rectangle, and the area of the 3 blue squares. We said you need to subtract them. Right? So take the big red one and subtract the blue ones, and that would give you the area of the grass or the green that I've drawn in here. Right? The remaining shaded area on the outside edge. Again, you could do that different ways. Right? So you could write it in one big string. You could write it vertically on top of each other. Because my answers are right beside each other, I'm going to, I wish I'd written it a little bit lower so it looked a little bit nicer. It's just like this far off. I just want to be able to just like drop it a little bit. We'll do it anyway. So, what I would do is I would say I want the red area minus the blue area. Like that. And write it as one big string. Right, so red area minus blue area. What does a minus sign do to that blue area? Changes all these symbols on the blue side. Right? I say the negative distributes in. Depends how you want to look at it. Right? I've run out of space, so I'm just going to write it down the side. But I would bring that negative in. The red stays all the same. So now I would have negative 3a squared minus 16a plus 64. And now it's a minus 12a squared. Then it's a minus 60a. And now it's a minus 75. This big equation would be the area of your grass or your shaded region. You'll notice you have some like terms that you need to combine. So if you look, I have some a squares that need to combine, Negative 3 minus 12 is negative 15a squared. Let your calculator do that work for you so you don't mess up your negatives. Okay, so negative 3 minus 15. Then I have some a's, right? So negative 16a, negative 60a. Again, let your calculator do the work with the negatives if you're not confident with it. So negative 16 minus 60 gives me negative 76a. And then 64 minus 75 gives me negative 11. This is the area of my grassy area region. Awesome. If you look at part C, it says determine the area of the grass if A equals negative 1.5. That means we go back to our formula we just created and we substitute negative 1.5 in. Right? Same way we did on the last question. So we use brackets to do it, and then we use our calculator with all the brackets to do it properly. You can give it a shot if you want. So try it out, see if you get it right. I'll write out what it looks like. So it would be negative 15, negative 1.5 squared, minus 76, bracket negative 1.5, and then minus 11. Make sure you're using minus signs and negative signs properly, right? So in my brackets, I have negative signs, which is down here by the decimal. But when I do like minus 76 or minus 11, that's the minus sign, which is above the plus. It's a little confusing. You'll get used to it as you use it more and more. I get 69.25. Be very careful with your negatives. Make sure you use brackets. If you want, you could calculate this in chunks too. Okay, so for instance, like I could calculate just this part. And so I could go negative 1.25 in brackets, or sorry, negative 1.5 in brackets, square it, and then times it by negative 15 to figure out that this is negative 33.75. And then I could calculate this guy, making sure it's 76 times negative 1.5, and I'm going minus negative 114, and then minus 11. And maybe that's a safer way for you to do it if it's not going in your calculator properly. Then you're just doing numbers, right? Negative 33.75 minus negative 14 minus 11. And you would end up getting 69.25. And so if you want to do it in chunks, that's fine too. That's actually how I do it. Trust issues. I don't trust my calculator. All right. Last one, which is kind of an extension for us, in case we don't do a lot of this. We're going to do a triangle question. I'm just trying to think. Yeah, we'll do it. So it is a bit of an extension, so it's a bit of a challenger. So maybe for if you're like hoping to do above 80% in the class, this is the type of question you have to be able to do or want to be able to do. It says the hypotenuse of a right triangle, right angle triangle. We've seen that before. It looks like this. 90-degree right there. Is 5x plus 5. So it said hypotenuse 5x plus 5. That means this is 5x plus 5. And the lengths of the other two sides are 4x plus 8 and 3x minus 1. It doesn't matter which one's which. Okay, so when you're talking about the other two sides, you could flip them and you'd still be right. Right? The only side that really matters is your hypotenuse has to be labeled properly. The hypotenuse being across from the 90. So that means the other two sides, I'm just going to put them in there. 4x plus 8. And this guy's 3x minus 5. Awesome. It says, form an equation to solve it to determine the lengths of the three sides of the triangle. Remember when we did triangles last unit and I said there's only one thing you need to know about triangles that you need to know? People are like, I don't remember that. Pythagorean Theorem. And that's the only thing I was like, you have to be able to know that one. That's what's going to be expected of you. Anything else, they'll give you the formula. Okay? So for this guy, we need to use Pythagorean Theorem. And that's how we're going to connect all three sides to each other. Like make them all into one big equation. Pythagorean Theorem is a squared, which is this guy, plus b squared, which is this guy, equals c squared, which is the hypotenuse. So let's build that equation. 4x plus 8 squared plus 3x minus 5 squared equals 5x plus 5 squared. Fantastic. Now they're saying to solve it. To solve means that you should end up with x equals some number. And that's how it should end. We're just going to work on expanding this thing first, okay? Because that's what really our goal. What we know is that you can't take squares and bring them into the brackets. The reason you can't do that is because this is a binomial squared. Remember that trick? And we said, don't do this. That only works for monomials. This is not a monomial. This is a binomial. Instead, we have to do something different. We have to scratch out the square and write it twice. Because that's what it means when you have something squared. It means you have two of them. Remember that trick? We talked about that. That's like over a week ago now because we had that break, right? We're going to do that trick 3 times. Okay, so we're going to do it for the first one squared plus. We're going to have to do it for the second one squared. So it's 3x minus 5. And another 3x minus 5. Equals, again, do that trick. So it's 5x plus 5 twice. That thing. We're creating a monster here. To solve that means you're going to have to multiply everything together. All right, I'm going to try to color code it so that it kind of sticks out where my multiplications are coming from. I'm also going to use distribution and combine like terms at the same time. All right, so it's going to go a little faster than maybe what you're used to. So if you multiply these two guys together and you do it properly, you should get 16x squared. Okay, and then you would get plus 64x. And then plus 64. So I use distribution, and then I combine like terms. Plus, I'm going to do it again. So now I've got this guy, 3x minus 5 times 3x minus 5. If I multiply those together, and I combine like terms, I'm going to get 9x squared then I'm going to get negative 30x. And then you get plus 25. Equals. And I'm going to do the third side over here. Again, I'm using distribution and collecting like terms. So it's 25x squared plus 50x plus 25. Holy smokes, eh? You'll notice after you do this, when you multiply all these things, you have a lot of like terms. Okay, so you can only combine like terms if they're on the same side as the equal sign. So for now, we can only combine these two because they're on the same side of the equal sign. If you get 16x squared plus 9x squared, that equals 25x squared. These x's can combine because they're on the same side, so I have 64x minus 30x, that would give me plus 34x. And then I have my constants, plus 64 plus 25 becomes plus 89. Equals the other side, which is 25x squared plus 50x plus 25. That's fantastic. So we took our triangle, we used Pythagorean Theorem, we actually distributed or multiplied our Pythagorean Theorem to become this massive equation here. They want you to solve for x. The only way you know how to solve for x is to put everything on one side of the equation. Right? So we move everything over, all the x's to one side. And then we put all the constants to the other side, right? And that's kind of a review from last year, so it's not expected that you have that nailed down yet, that's for sure. And we will definitely do more of this like later in the year and review it and how to properly do it again. So if that's kind of like, whoa, I don't remember that, that's okay. All right? If you do remember that, what it means is we push everything to one side by using opposite operations. So for instance, if I wanted to move this 25x squared to the other side, I would subtract 25x squared from both sides. Then if I wanted to move the 34x to the other side, that means I would subtract 34x from both sides. And if I want to move the 89 to the other side, that means I would subtract 89 from both sides. And on the left-hand side, where you were moving things over, you're going to notice things keep canceling out, right? 25x squared minus 25x squared cancels out. 34x minus 34x cancels out. 89 minus 89 cancels out. The entire left-hand side now equals 0, right? It all got moved to the other side. On the right-hand side, 25x squared minus 25x squared cancel out. 50x minus 34x equals 16x. And 25 minus 89 equals negative 64. So, okay, good. Make that. Awesome. Once you have everything to one side, now you can separate it out. So we say, like the phrase I'll use is get x by itself. Okay, so if you want to get x by itself, you need to move the 64 over and then move the 16 over. And you do one thing, then you reorganize your work, then you do another thing, and then you reorganize your work. And you just keep following that process until all the x's are by themselves. In this case, I'm going to add 64 to both sides, so that I move the 64 to the other side. After I do something, I reorganize. So on the left side, I now have 64. On the right side, I now have only 16x. Now I need to get rid of the 16. The opposite operation of the 16 would be divide, because this is 16 times x. So I divide both sides by 16. That reorganizes to be 4 equals x. That means x is 4. You could then look back at your side lengths and change x to be 4 to figure out the actual measures of all 3 legs of the triangle. That's like a crazy intense question, right? That's very challenging. The question did ask you for the side lengths. Okay, so that means, I'm just like a hair too big. The question asks you for the side lengths of the triangles. That means you need to take x equals 4 and put it into your side length formulas for your triangles. And then figure out what all 3 lengths are. The first length would be 4 times 4 plus 8. 4 times 4 plus 8. So that means that side length would equal 24. The next side length would be 3 times 4 minus 5. That would equal 7. That was scary. And then the hypotenuse would be 5 times 4 plus 5, which is 25. So your 3 lengths of your triangle were 7, 24, and 25. Crazy, hey? People are feeling like, hey, I'm really good at this unit. Then we did that lesson, hey? And people are like, whoa, that's scary. I see eyes like this for the first time all year, where it's kind of like, that was a lot. This is like extremely hard. So that's as hard as it's going to get this first half of the unit. You aren't going to get to a test and have 10 questions like that. You might have 1, maybe have 1, and probably not to that extent. Okay, but if you could do that and you followed me through that and you're like, I think I could do that, then things are looking good for you, okay? You can do, I think that's the last question of this assignment, right? Yep. You can try this assignment. I would definitely try questions like this, where you're trying to figure out the area of the shaded region. You're going to see stuff like that again. But if you're still feeling like I'm maybe not that strong at multiplying, I would go back and keep practicing this stuff. Until your multiplication skills are down pat. Okay, so do those previous assignments first. You need to have very strong multiplying skills before you start trying to apply multiplying skills. Right? So if you haven't finished these and you're not confident with your multiplying, go backwards and do some of those. And that's where I think most of us are probably at. Okay, so like no shame in it. It's just smart studying. Right? Study the stuff that's more important, foundational skills.